Welcome to today's session. Now we are in the paper Advanced Computer Architecture. Okay. So as I told you in the morning, in case if you are facing any signal problems, please be on the line. Even all of us are facing the signal problem. Okay. Suppose either one of us line is disconnected, please be on the line. Those who are having poor signal, please go for YouTube. There I provided this train. Okay. So under this paper, Advanced Computer Architecture, now we are discussing the first unit. Under the first unit, we are seeing the fundamental concepts like what is parallelism, what is parallel computing model, and what are all the types of parallel computers. So like this. In the last class, we started system attributes to performance. It's a new topic to us. We started this concept. So what I said about system attributes to performance, or in short, what system attribute is, what a system attribute is. See, for each and every quantity on the real world, every quantity is having some performance measures provided with the attributes. You take your role, you are a student. Okay, near 11 students are there, 11 or 15 students as an average, I think. On your second MSc class, there are 15 students. So how to assess each student's performance? How to know about the student, each student? So for knowing about each student, we are using some measures, matrices. What about the percentage of each student? What about the attendance of each student? So like this. So there, while assessing the students by using these measures, these attributes, they can easily classify this student is well and good, and this student is average, and this student is like that. So all the quantities, all the real world quantities are having some measures and attributes. And that measures and attributes are used for evaluating the performance of the real world quantity. So like that, in our computer field, we know well, computer is a machine. Basically, a normal computer, a sequential computer is a machine used for doing calculation more fast, used for doing the calculation at high speed than the human processing. So when we started such a concept of computing, there the comparison is started. How fast the computer is, how fast the computer is producing the result than the human. Compared with the manual processing, how fast the computer processes. Okay, so there the comparative process is started. So within the field of computers, the performance of machines, computing machine is definitely a needed concept. But practically we are using computer. We started to use our computer, laptops, even mobiles, without considering the performance measures, how fast the machine is, how fast the device is. But at one extent, we will come to know about the performance of the devices that we are having. You take an example also. You purchased a new laptop. Over that laptop, you installed the Windows operating system and you installed all the needed software. In the beginning, the laptop works well. It performs the process more fast. So on the timing, you are not caring about the performance. But when the usage is going on, after 3 or 4 months, the laptop will produce the result with a delay. So on the timing, you'll come to know about, okay, you come to know about the performance of your machine, why the machine is slower. Now the laptop is doing the work a little bit slow than the beginning. So under such stage, you will come to know about the performance of your machine. So the concept, performance is an important aspect within the field of computers. So what are all the performance factors or attributes that affects the field of computing or computers? In the sequential environment, we know well the output. Very simple measure within the field of sequential computing, within the field of sequential programming, sequential computer programming, the performance of a computer is measured by taking the output timing. Any name is there? Yes, throughput. What we are calling that? Throughput. Throughput means what? How fast a machine is producing the result. How fast a machine is producing the output. So the performance of a sequential computer is easily measured by assessing the timing of output. So by considering that concept, how fast a computer is producing the output will fix the performance of a machine. This machine is doing well. This machine is producing the result little bit slow than the first one. So after assessing the performance, we will only consider the machine, okay, we will only consider the machine which produces results more fast. So it's the importance of performance within the field of computers. So here in our topic, you see, in our topic, that means system attributes to performance. As per your syllabus, in our topic, what we are going to see here, we are going to see such a concept, such the attributes which are affecting the performance of computers in general. Whether the computer is a sequential computer or a parallel computer. Okay, whether the computer is a sequential or parallel. Here we are going to discuss some features, factors, attributes which will definitely affect the performance of a computer. Okay, so in the last class we started this. So what we said on that last session, first I said one point. So what that one is, the ideal performance of a computer needs a major requirement. That means a perfect match between the hardware and the software. That means the machine capability and the programming behavior. I said this. So what is the meaning, sir? Suppose a computer is there. Before going to assess the performance of the computer, we are having a thought on our mind. Now we are going to assess the performance of the computer that sits before us. So we will believe the computer is doing the work more fast. The computer produce results more fast than the human process or the other computers or with the other computers. So we are thinking like this. So what we are having on our mind before going to assess the performance of a computer, the computer performs well. It produces the result at most speed. So we are expecting that. We are expecting a computer has to produce the result more fast. So that expectation is known as ideal performance. But that ideal performance is heavily depend on a perfect match in between which one? machine capability and the programming behavior. That means hardware and the software. Both hardware and the software. We know well, a computer is comprising of two things as a major fact. What are all the hardware devices and the software components? So both components, both hardware and the software, must cooperate with each other in order to produce the result more fast. Okay, so what about the meaning of the first line? Ideal performance of a computer needs perfect match between machine capability and program behavior. So what it means? It means both hardware and software on a computer must cooperate with each other to produce a result more fast. Then only we'll get an ideal performance. In practical, we cannot get ideal performance. What is the meaning? We cannot expect a machine is producing the result more fast. Okay, it involves several factors that what are all the factors that we are going to discuss? Okay, so I said this machine capability can be enhanced with the needed hardware technology, architectural features, and the efficient resource management. So the machine capability is always discussing the hardware side of a computer. Even I said one important point. From the hardware point of view, from the machine capability point of view, there is no major problem at all. Okay, especially for parallel processing, the field of hardware supports the circuits. But doing that work, doing that parallelism by using a software is a difficult one. Okay, we discussed that. So as a third fact, I said this programming behavior is very difficult to produce. Even the delay produced by a computer, a delay on a computer is heavily depend on the software side, whether it's a sequential computer or parallel computer. There is no problem at all from the hardware side. I told you already. But from the software point of view, there might be a delay. So the main cause of delay, it's an important point, you have to note it down. The main cause of delay occurred in the performance of a computer is arising from software side. So what are all the factors that affects the performance of a machine from the software point of view? Algorithms, data structures, programming skills, and the language efficiency we discussed. Okay. Moreover, a single machine performance will depend on the program. I also said this point. For one program, a machine will produce a result more fast with a shorter period of time. At the same time, the machine will take longer timing. The machine will take longer timing. Machine will take longer timing. The same machine which produces the result with a shorter period for a program can also produce a result with a delayed time. So it depends on the program process. Okay, so the machine, overall machine performance heavily depend on the programming process also. So at last we have seen this, the peak performance, it means maximal performance. We cannot expect the peak performance, that means the ideal performance in practical. It's very difficult to process. Okay. Even at certain extents, machines will not have the average performance also. So we are assessing the performance at one extent. We are expecting the ideal performance first. The machine has to produce the result more fast. That one is not possible. So what about the next case? Next we are coming for the average. Okay, the machine is not producing the result more fast. At least the machine has to produce within the allotted timing, within the period of this. Even at certain extent, we cannot expect that average performance also. Okay, so by considering all these facts, we concluded this. So what is that, sir? Performance measure of your computer is not a single quantity. It involves lot of benchmarking and measurements. Okay, and the factors like algorithms, data structures from the programming behavior. Okay, so the most fundamental factors that are projecting, that are assessing the outperformance of a computer is what are them? Turnaround time, clock rate, and CPI, and MIPS. So I concluded with this on my last session. Right. So now we have to discuss what are the fundamental factors one by one. So first, we'll take the turnaround time. What a turnaround time is? Very simple. What a turnaround time? It's a simple measure. Turnaround time is a simple measure, and it is used for assessing the performance of a program. Even we can say like this: a turnaround time is the full duration of a programming process, or full duration of a program to complete its work. So what I'm saying, you see, a turnaround time is a process timing. Again, I'm saying, you see, the turnaround time is a duration. Turnaround time is a duration, full duration of a program, which has to complete its work with the help of devices on a computer. Okay. So what I'm saying, you see, turnaround time is a duration, full duration of a program, which has to complete its work, which has to complete its work by using the devices on your computer. So what are all the devices involved? Memory, processor, I/O. Okay, so the turnaround time is a simple measure used for assessing the performance of a program. Okay, just a minute. Okay, so the turnaround time is a simple measure used for assessing the performance of a program. I said it's a duration, it's a full duration utilized by a program to complete its work by using the devices on a computer. Okay, so figuratively I have shown that. For your understanding, I put a diagram under the slide. You see the turnaround time, the full duration of a program. You just imagine the human on the diagram is a program, the full duration of a program to complete its work by using the devices of a computer. Okay, so the turnaround time involves several facts I said. So what are all the factors that are included within the turnaround time? The turnaround time involves disk and memory access. Suppose for a a program has to read the memory. Either the program has to read the primary memory, for example, random access memory, main memory, or it has to access the data from the secondary storage devices like hard disk. So the program has to read the data from the memory, and at the same time, the program has to write the result to the memory, either to the primary memory or the secondary memory. It involves timing. You follow what I'm saying? It involves timing. Definitely, the memory read and write process needs the memory read and write process needs more time. Okay, so definitely the memory read and write process requires more timing. Then So the turnaround time involves this. The turnaround time is involving disk and memory accesses. The next thing, the next factor involved within the turnaround time is what is that? IO activity, input and output activities. For example, a program has to read the data input from the keyboard. For example, you take it. Like that, the same program has to produce the result on a monitor or a printer. You follow what I'm saying? The turnaround time is involving these factors, disk and memory access. That means read, write, memory read and write process. Either the memory is primary or secondary. The next thing what I'm saying, you see, the turnaround time is also involves what is that? IO activities. One program may read the input from the keyboard, or a program may send the result to where? The monitor, output device, or to the printer. So it also involves timing. Reading of data from the input devices. Like that, sending of result to the output devices involves timing. So a program has to came across all such timing in order to complete a task. Sir, what you are saying? A program has to use this. So when a program is run by a processor on a computer, the program accesses the memory, the program accesses the secondary storage. Like that, the program is reading the data from input device and writes the results to the output device. Okay, there is no problem at all. There is no problem at all when the processor is executing a single process. But in practical, even a microprocessor or on a sequential computer is doing more than one work in an overlapped fashion. We did that. What about overlapping, pipelining? In a pipelined manner, a processor on a sequential computer itself is doing more than one process at the same time. At the first allotted time, the processor may read the data from memory. In the second allotted time, the processor sends the results to the output device. Okay, so the processor has to concentrate on all activities. Suppose a processor may read the data for a one process. The same processor may send a result for another process. So definitely a program has to wait for some time till the completion of processor to do the work. To complete the read write on memory, or to read the data from input, or send the results to outputs. Okay, so as a overall turnaround time involves this as a first one. Okay, so what's the next, sir? Disk read and write. That means memory access. IO activities are all not at all the factors. The turnaround time of your program also involves compilation time and OS, operating system overheads, and lastly, you see CPU time. So what is said about turnaround time? Turnaround time is a duration, full duration of a program to complete its tasks with the help of devices, resources on a computer. So here I am saying the turnaround time involves several factors. First I said the memory read and write and IO activities. The turnaround time also involves, I'm saying the turnaround time also involves, what is that? Compilation time, OS overheads, and the CPU time. Definitely, you take an example. For example, you take a program, Java program. You have written a Java program with a 10 lines of statement. Now the compilation is fast. During the compilation process of your program with a 10 statement, the compilation is more fast because it involves 10 statements. Suppose you consider a Java program with hundreds of lines. So what will happen? Definitely, the timing for entire compilation will take a delay. Definitely, the compiler produces the machine code with a little bit of delay. So it is also a phase included within the turnaround time of a program. Like that, OS overheads, operating system overheads. So what an OS we know well. Operating system is a controlling software which controls the activities of a computer by doing 5 kinds of work, well, memory management, file management, IO management, like that. Process management, that means process scheduling, so like that. So during the concept, even during the running time of your program, the operating system, at certain extent, the concerned operating system failed to allot memory due to the lack of memory location. So on the timing, what we are saying, there might be a OS overhead. The OS has to resolve that, but till the resolving process, the program has to write. Till the completion of a OS overhead, the program, the running program has to write. So definitely the turnaround time is also involves which one? OS overhead. And last, what is that, sir? CPU time, the overall time needed to complete the entire program, started from the memory read to the sending of output to the output device. So what is that? That is CPU time. Okay. So what we have to conclude here? What we have to conclude here? The turnaround time of your program must be shorter one. The duration of turnaround time. Okay, the duration of turnaround time must be a shorter one. It should not be a longer one. So when a turnaround time is shorter one, turnaround time of a program is shorter one on a computer, then only we can say the performance of a program and the overall computer is best one. So as an important fact, by considering the turnaround time of a program, we can assess the performance of a computer. So it's a point we have to mind it. Okay, so in order to shorter, okay, sir, what we said, the turnaround time must be shorter one and it should not be a longer one, I said. Okay, how to shorter the turnaround time? By considering even to reduce all the time factors that we listed. So what we listed here, disk and memory access, IO activities, compilation time, OS overheads, and the CPU time. So by optimizing all these, the timing of all these factors, we can automatically reduce which one? The turnaround time of a program. Okay, so these are all the points we have to consider related to which one? Turnaround time. Okay, sir, you said all these things. The points that we said up to this are valid for both sequential and parallel computers. Now you take the turnaround time specifically for multi-programming, that is our case. In our case, what is that? Parallel programming. See, under the parallel programming or multi-programming environment, definitely there is a conflict in between IO and OS overheads, system overheads. Definitely there are problems, practical difficulties that occur within a computer, within a parallel computer or a multi-programming computer. Both OS overhead and which one? IO must try to access some resources at the same time. Even both IO and system overheads, that means OS overheads, overlap, try to overlap with the CPU time. Here we can say an example. Suppose one program may try to access the input device, tries to get an input from the keyboard. At the same time, the operating system is also trying to access the keyboard. You follow what I'm saying? The program tries to access an input from the keyboard. At the same time, you see, at the same time, the operating system is also trying to access the keyboard. So what will happen? So here, both IO and system accesses are overlapped with each other. Okay, so now only the CPU time is to be reduced. Otherwise, the CPU time is producing a delay. Both overlapping of IO That means IO, overlapping of IO and system overhead. Voice overhead definitely affects the CPU time. Moreover, it's very difficult. It's very difficult to measure such a total CPU time needed by a program on such environment where under parallel computing environment, it's very difficult. As a CPU, central processing unit, on a parallel computer or a sequential computer, that CPU must try to satisfy both system, that means operating system overheads and the user needs. Then only we can say the CPU is doing well. Importantly, the CPU has to concentrate on which one? User needs. Okay. So now we completed which one? Turnaround time. Next, we have to go forward clock rate and the CPI, cycles per instruction. So here I would like to wind up my session. In the next class, we will do the CPI, clock rate, and other things. Okay. So now I'd like to wind up my session.